Welcome to part 2 of 2.3 polynomial functions. Our essential questions are still the same, so we are working on what information we can determine from a graph of a function and what is a quadratic function. So, multiplicity and x-intercepts. If r is a 0 of even multiplicity, then the graph touches the x-axis and turns around at r. If r is a 0 of odd multiplicity, then the graph crosses the x-axis at r. So regardless of whether the multiplicity of a 0 is even or odd, graphs tend to flatten out near their zeros with the multiplicity greater than 1. So in this example, find the zeros of f of x, -4 times the quantity x plus 1/2 squared times the quantity x minus 5 cubed. And give the multiplicities of each 0. State whether the graph crosses the x-axis or touches the x-axis and turns around at each 0. So, we want to find the zeros of f by setting f of x equal to 0. So, we have x plus 1/2 squared equals 0, so x equals -1/2. And x minus 5 cubed equals 0, so x equals 5. So this means x equals 1/2 is a 0 of multiplicity 2 because it's squared. So since it's an even multiplicity, so even multiplicity means it touches at the x-axis. X equals 5 is a multiplicity of 3, so that means it crosses at your x-axis. So for this function, the graph will touch the x-axis at x equals -1/2, and the graph will cross the x-axis at x equals 5. Your multiplicity is your exponent. So this is an even exponent, that's an odd exponent. The intermediate value theorem. Let f be a polynomial function with real coefficients. If f of a and f of b have opposite signs, then there is at least one value of c between a and b, for which f of c equals 0. So that means it crosses somewhere in between a and b. Equivalently, the equation f of x equals 0 has at least one real root between a and b. Show the polynomial function f of x equals 3x cubed minus 10x plus 9 has a real 0 between -3 and -2. This means we're going to evaluate f at -3 and at -2, and if they have opposite signs, then there's one real 0 between them. So we're going to solve for f of -3 equals 3 times -3 cubed minus 10 times -3 plus 9. So we have 3 -27 minus -30 Now you do f of -2, and you use the same equation. You're not changing your equation at all. So if you look at these two equations, f at -3 is -42. F of -2 is a positive 5. So these two flipped signs, so that means there's a real 0 between -3 and -2. So the sign changes to show the polynomial function has a real zero between -3 and -2. Turning points of polynomial functions. In general, if f is a polynomial function of degree n, then the graph of f has at most n minus 1 turning points. So all you have to do is look at your highest degree. In this case, the highest degree is 8. So n equals 8. So n minus 1 is 8 minus 1. So that means the graph has at most 7 turning points. Answer the questions below and then watch the next video. On the next video, we are going to talk about graphing polynomials. So we're going to use all of this stuff to graph.